Perfect. So, as everyone is familiar with at this point, the Stratix line covers a vast amount of products we have. We've had some new additions to it with we will talk about in the future. We've had some changes, and we've had some stable factors. Stable factors would be the 5800s and the 5200s, which at this point, most of you have probably touched, worked on, troubleshot, all that good stuff. Wayne, next slide, please. So, on to our first new addition. The Stratix 2000 is going end of life and will be replaced by the Stratix 2000 or 2100. So, two of the things that for me are the biggest features that I'm a big fan with these would be the broadcast storm protection and quality of service. It's going to give you a little bit more stability in an unmanaged environment. I still being a networks guy, much prefer a lightly managed or managed switch, but if it fits your application, this is a perfect solution. So here is probably one of my favorite concepts of networking, is once we get into redundancy. With me coming in from an IT background, I'm used to heavily redundant networks, redundant servers, redundant switches, the whole nine. PRP is undoubtedly my favorite protocol in that aspect. We have 0 millisecond recovery times, independent paths, and the benefits, honestly, they go on and on. Now, for our resilient side of the fence, we have the DLR, which you all know and love. DLR is a great protocol, simplistic, relatively easy to set up. Like both, it has its downsides, but fast recovery times, easy to set up, easy to train on. It's great offering. Now, to go a little bit more into DLR. DLR simplicity comes down to a couple pieces. One, when configuring through the GUI, great. Very easy to do, easy to work with. Set of paths, A, B, and you're off to the races. Another nice thing about this is it uses only a single LAN. So you just have one giant ring network. I don't have any extra add-ons or anything like that, which, once again, brings in that simplicity factor. Another great piece to it you're going to run into is the recovery time. There are plenty of other ring solutions out there. Some you're also familiar with, like you've seen Rep, you've seen Spanning Tree. Those have recovery times, but not to the same extent that DLR does. DLR, we're going to be pushing that 3-second recovery time with our process applications and general automation applications in general is perfect, right? We don't want the moneymaker to shut down. And if it's a if it's a safety thing, we really don't want it to shut down. All right, now back to my golden child, PRP. Love PRP. You've got it when you have your two LANs, it is sending the same data packet on each side at the same time. And that means, say Larry the engineer wants to cut one of those cables in half. Don't know why he wanted to, but he did. You have a 0 ms carryover, right? You are up and running. You are golden. Another piece that, and this brings on one of my favorite parts of this. I'm going to throw a jab at Microsoft here. PRP is designed to be up 365, right? We want it up. We want it running constantly. Unlike Microsoft Office 365, what likes to go down like once or twice a month. This is a redundant solution for applications that matter. You have lives at stake. It's a big money maker, right? Oil, gas, we see how we know what those numbers are like. This, when it comes down to it, if you are in a spot where you're debating, well, we could do costs for PRP or DLR, look at the numbers that it's producing, right? That's where it comes in at. Those big ticket projects, big money makers, safety solutions, where you don't want people, you want people to be able to see their loved ones when they come home and all that. PRP's a winner. All right. Stratix 5200. So, a couple big things with the 5200 that I would like to point out. are, we're going to start with the base firmware and the full firmware variant. The base firmware is going to be more akin to one of our lightly managed switches in the past. You're going to lose functionality. So you won't have access to DLR, you won't have access to PRP, and you will not have access to NAT. There's a couple other things I remember that they're having limited access to as well. I need to go back through and find them, but if you would like to find out more on the differences, please reach out to us. We'd be glad to go through them on a one-on-one basis and really break it down. Now, for a second piece, and I've run into this in the field a couple times now with troubleshooting and helping people out, these, for some reason, do not come with the SD card. The SD card, think of it kind of like your life alert, right? The SD card, you're going to back up that configuration onto, and then something goes awry, power is lost at the plant, boom. You can recover from that SD card. The other convenient thing about that is as long as you're in the 5200 line or any of the Stratix, the newer Stratix lines, as long as you're not doing the Layer 3 stuff, you'll be able to use that configuration and you can put it on other Stratix switches in the current iOS XE environment. So here are the model numbers that will support the catalog designations ending in P, DP, and DN. These will all support SIP sync. DLR is supported by DP, DB, and DN. And if you need NAT, it is supported on DN. Now, one nice thing about the DN model that I gravitate towards and recommending is it supports up to 2 rings. So you could run 2 rings in this situation if you needed to, in the event that you've got 2 different systems that you want to somehow connect to the same switch. You have that capability. Next. All right, on to the 5800. So this is a wonderful replacement to our previously modular switches. Now, there are a couple caveats to it. It's fully modular, but you are going to run into a couple different things. One, the part numbers for the expansion module need to match up with your base unit. So if you have advanced firmware, it needs to be advanced firmware. If it's a PoE situation, so on and so forth. If you have questions about that, please let us know. We'll be happy to help, happy to get that sorted out for you to get you in the right direction. Another thing that I really like, and I'm just going to wrap this all into here, with the new 58s and 5200s and it being on the iOS XE, if you are in a situation where IT is demanding a Cisco solution, this can be integrated into those softwares that a network admin or a SOC would be using. So it's still a very viable solution. The nice thing versus Cisco is you don't have to pay for your maintenance, right? So the Cisco's you can set it from 12 months maintenance all the way up to like 5 years. Here, it's all bundled in, good to go. All right, so here's a wonderful table of the models of our 5800 and the models that would, the expansion modules that coincide with it. Right, you see, we have, so we'll go to the bottom one, the 1783 MMF10EAR. That would also need, we need to find one of the designations with A at the end, and then that will match up. We'll make sure we have the routing cable. Well, needs to match up with that piece. So back to what I was saying earlier, DLR with the new Stratix is very easy to configure. You set the mode, so if we need this to be a supervisor, set the supervisor. Then you just set your paths 1, paths 2, away we go. Very easy setup. Gonna be a great way to give you some resilience, back up your, keep things running. Oh, yes. And you can find these diagrams on the GUI, you can find them in the manuals, help bring you to where you need to. We can go to the next one, fine. All right, so we are almost at the point where I can say I'm not lying. about the ETAP being replaced. As of right now, we are looking at a June 2025 release date for a brand new ETAP and the dropping of our previous ETAP line, with the exception to the conformally coded versions. Those we are looking at January 2026 and March 2026. So June 2025 for end of life of the current ETAP, October 2025 for the current modules, aside from conformally coded, going end of life, or going, oh, go to the next one, please. All right, so here we have our wonderful new ETAP, how it's gonna look. This ETAP I am very excited about. We're gonna have gigabit capabilities with it, SFP options, and for the most part, a drop-in replacement. One slight caveat to that is the new model ETAP is slightly higher than that. And the next slide will go into the dimensions of it, so you can see what we're talking about, the slight size difference. Thank you. So here we are. Here's our wonderful dimension slide. We're going into, as you can see, we still have 3 Ethernet ports, but we can now do a mixture of, if I remember correctly, we can do up to either 2 Ethernet ports and SFP or 1 Ethernet port and 2 SFPs. And as you can see here, right, if we're looking at the dimensions, we do have similarities, but there are some differences, right? So fit and form is going to be an important part. All right, Jacob.
Thanks, Tyler. I'll be taking over from here. And hi, everyone. If you don't know me, I'm a technology consultant for Rockwell in the Houston area. Talking about the Stratix 4300, last switch family we'll talk about today, and FactoryTalk Remote Access as a software solution. So firstly, what is FactoryTalk Remote Access? Well, it's our software that essentially manages remote access through a web browser, and it's accessed through FactoryTalk Hub in the cloud for those that are familiar with it. And it enables VPN and RDP connections. So on a high level, that's what it does. So through FactoryTalk Remote Access, you can initiate your VPN connections and locally or remotely register your devices in the manager. And then you can establish user and group permissions, as well as temporary role-based users for who can access, manage parts of the firewall, who can remote into different devices. There are also event logs that are tracked for domain activity and then also remote connections for your devices. And through that, you can perform filtered searches. So just like Asset Center, if you're familiar with that, you can find out who, when, where, what happened in the domain on the devices. So you want to see who remoted in this week, or what devices have been accessed in the past month. You get full access to that information that's tracked. And you can configure remote access endpoints through the browser. This would be your Stratix 4300 router and the FactoryTalk Remote Access runtime itself. On the right, you'll see that we have some panels, some awesome 6300 PCs, and edge compute modules. Each of those will function as endpoints by default for remote access. So you can remote directly into those devices, while the Stratix 4300 acts as a router to devices on the network to access any device that's connected to it. I can go to the next slide. So for the router itself, the Stratix 4300 is a remote access endpoint that used to be limited to just hardline Ethernet connections and serial USB. But now if your industrial network is not as robust or is very dispersed, we have additional offerings for Wi-Fi and or cellular remote access. So those would be on the right. You have the 2 middle ones. Those were the original 4300s. And now the 3 to the left and 3 to the right of those center ones are cellular and Wi-Fi enabled options. And all of those support gigabit Ethernet connections, serial and digital I/O. So they all come with the same capabilities or better. Installation is quick and easy into an existing remote network where a runtime cannot be installed, or for where network separation is required. And we have protections against unauthorized domain modification. So whenever a FactoryTalk router is reset, the router retains its original connection to the domain. if someone tries to reset it, they don't have immediate access to setting anything up new or getting access into the system. And you can use hardware commands and the digital I/O that's enabled on all of them to control connectivity to the local machines. And then you can see we have the part numbers there, as well as gigabit rates for their wide area networks and local area networks, how many ports they have. So we have a lot of different options depending on what your needs particularly are. So in process, FactoryTalk View SC and remote access typically go hand in hand. So with remote operations, that's becoming more and more popular nowadays, as well as with maintenance and troubleshooting. You don't want to keep an engineer on site at all times, or engineers currently at home. You need someone to go in and fix something when something's down, or just be able to help out. It's very important to be able to have access to the process system. So our user or expert on the left, well, picture down there, can VPN tunnel through the top line directly into, for example, an Awesome 6300 industrial PC, which is natively or out of the box enabled for FactoryTalk remote access. Or you could go in through the router for the Stratix 4300 router, for example, and access that industrial PC. And then while the server infrastructure in the middle maintains communications between the local PC and the network system and the remote network. So that would be in the cloud through FactoryTalk Hub. So remote access basic, which comes with a lot of the edge compute modules, the Awesome 6300 industrial PC. That basic allows for connectivity directly to the PC running View SC and the applications installed locally, while the Remote Access Pro, which would be installed on the Stratix 4300, enables visibility to the PC and any other device that's on the network connected to it. Next, we'll go into Rockwell's automation device, Rockwell Automation's device object library. Sorry, speaking over myself here. So our device object library, this is robust and a free to download tool for anyone. And it integrates Rockwell Automation's and partner hardware into Logix instructions for Studio 5000 design environment, and provides HMI objects for USC, for optics, that you can just drag and drop into your designer or into your HMI development platform. You drag and drop and then have full access to their information without having to do any manual coding or custom work. And the library covers our portfolio, and it's pretty much in its entirety. It's split up into different categories, as you can see there, the 6 different categories. You got power, network, safety, I/O and I/O link, as well as condition monitoring. So these would give you access to your device parameters, for example, for easy drive configuration and pre-made faceplates, so you can have a consistent look and feel in applications. And this is a big touch point for PlantPAX. A selling point is that consistent look and feel, and it heavily relies on the device object libraries. So whether you're getting a project commissioned or you're doing it yourself, you have a set of standards that you can follow so that everything looks the same, and you don't have to rework to make new faceplates. The person on the end user side doesn't have to learn a new system every time they're accessing a new page or a new part of the plant. We'll focus primarily, and yeah, there's that one little switch got that faceplate got the one little animation. We'll focus specifically on the network device library, and it covers all of our Stratix managed switches. So 2500, 5200, and anything that's newer will be added onto there that Tyler's talking about if it's not currently there. These are constantly being updated and given new features. And it supports, so the whole network device library supports device level ring and PRP, parallel redundancy protocol. Tyler's golden child supports those network configurations. And these faceplates, these objects, we'll go into them in a little bit, but they give transparency to network details and diagnostics, such as, there's a whole list down there, but you got your model numbers, your IP addresses, and your device and network statuses. All important information that comes directly to your fingertips. So what you're seeing here are the navigatable tabs in a managed switch faceplate. So this is a Stratix 5700. We've got 5 different tabs here, or additional details in a tab. On the left, we have the home page, and it shows our port layout and port statuses along with switch information. So green are connected and healthy, and the yellow ports are not ready yet. And then the next tabs provide more of a detailed overview of the switch itself status and information, as well as for each of the ports. As you can look, you can see how many octets, unicast, non-unicast, all the statistics are being kept in track for each individual port and available for you if you want to drill down into it. So these faceplates also track the last 4, so on the faults and faults detail side. They track the last 4 faults and alarms, and they give detailed descriptions of what those faults or alarms are, as well as troubleshooting steps to help resolve your issues. So instead of having to get an IT person, go into the switches, now we bring IT and OT together and make it so that an operator or engineer can more easily determine what is currently wrong with the system instead of having to access the UI for the switches themselves, unless it's absolutely necessary. And all of this is pre-made by Rockwell. Again, free to download. I want to emphasize that heavily. And it's built into the firmware of our process controllers. So that's another discussion. But they can either be downloaded or come out of the box in the firmware for some of our controllers. So next we have the device, network device object library. It supports device level ring, up to 3 rings. So 1 ring, many different nodes, up to 3 rings. And it pulls all that information together from the controller if it's connected to the HMI. So you can visually determine the health of the ring and each device that it is composed of. And then the faceplates that you see down on the right-hand side, actually the whole bottom, provide a more detailed view of the ring itself, such as like active supervisor, active redundant gateway details, and ring statistics. So actually the left-hand side, usually what I see in, say, a Plant PX solution is I have one page that's typically showing all the whole network health, all the controllers, I/O, switches, drives, all in one page. But here you can have it be a pop-up built into the faceplate. So that same left graphic showing the device level ring, I just like having that on a page so you can see the full plant at one time, but also built into the faceplate itself. And while we also get node details for each device and network fault detection with details and locations as well. So visually, we can see in the device level ring image, we can see what devices are currently not connected, where the fault is, or the issue is, but then also in the fault tab, we can see more detailed information on what the IP address is of that fault and all the diagnostics that we might need to correct an issue. All right, lastly, PRP again. So the network object library, PRP faceplate, also takes information from the controller to the HMI. So again, just like before for the device level ring, we have the home page, which shows us our IP and MAC addresses, our LAN connection statuses, and the port details tab can give you more detailed information on port A and B statistics for each node, as well as we can get fault information and hardware and fault details. So all of it is free to use and is basically just a drag and drop. You connect what you need to, but no custom coding required for any of these. And from a use case standpoint, speeds up development time, provides a consistent look and feel across different projects and deployments, and simplifies the consolidation of information to give people what they need from viewing privileges, editing privileges, for network side, mostly viewing privileges, have easy access to diagnostics and the health of the networks. Now I'll pass it on next to process automation and power systems.
All right. Thanks, Jacob. Appreciate that. My name is David Newt, and I'll be talking about intelligent power the rest of the time here. So first of all, let me kind of frame our discussion. What we're talking about at a high level is traditionally your process control system controlling, you're connected to your hardwired IO instrumentation, and maybe some skids that are connected to the overall plant. That's kind of your traditional process control system. What we're going to talk about today is intelligent power, and what we mean by that. Well, effectively what we mean is connecting the power devices, so whether those are drives or MCCs, overload relays, even switchgear, can have the ability to connect those devices into our process control system, so we can act more intelligently when we have issues, when issues arise at the facility. So traditionally, a lot of the electrical devices have been hardwired to the process control system. So typically, you may see a trip in your process control system, but you have a limited amount of information about troubleshooting that trip. In an intelligent power system, because it's networked together, you have much more information, actionable, detailed information available to you. Not only what tripped, what device is it, what electrical device is associated with it. So let's say you had a pump not turn on. Well, that's connected to a motor that maybe a starter is connected. It's in the MCC. What if you were networked to that MCC, and that soft start had detailed information about what caused that trip? In a intelligent power system, you'd be able to see that and see that information from the plant-wide HMI, and presumably have a much shorter unplanned downtime situation, because that operator has more information in front of him to more quickly troubleshoot that issue. So that's really what we're talking about at a baseline, is really an intelligent power devices, and essentially that means we're connecting via network all those power devices into the process control system that's already networked together. You go ahead and go to the next slide. So even with intelligent electrical and power systems, oftentimes today those electrical systems are put on an island in and of themselves. So the example here on the left, we have our process system, and even in this process system has a motor control panel connected to it, but your switchgear is on another system. So you have two different visualization systems. They may or may not talk to one another. Even if they do talk, there's really just one pipe, and that might be limited information. So if you had a serious power issue that took out your process system, then the process guy has to call the electrical guy and say, hey, what's going on, instead of putting that together. So on the right hand side, you have all of that encompassed into one system. And we'll talk more details about how Rockwell does that, how we do that. But the idea at the end of the day is a more efficient system, creating more intelligence, and ultimately reducing unplanned downtime situations. And go ahead and go to the next slide. I think, yeah, there you go. This one, my slide looks a little different. We're missing some graphics on this slide, but I can speak to it a little bit before we move on. Essentially, what we're talking about here, oftentimes in the intelligent power control side, there's a new standard, and traditionally, when switchgear would trip, there would be one primary trip, and there'd be a lot of secondary trips that would trip very fast, oftentimes in a millisecond level difference between the first trip and, say, the 10th trip or the second trip or the third trip. So all of those, to be able to trap those and understand those trips, you had to have a hardwired system that would have millisecond resolution, and that created a lot of complexity and a lot of extra wiring in order to capture that information and put it into an actionable format. Several years ago, there was a standard network protocol called IEC 61850, and that 61850 technology is able to capture those trips from the switchgear via millisecond resolution and communicate that out over a network to an automation system or to an HMI system or a SCADA system. And so that's really the kind of the increase in technology that's happened recently to make intelligent switchgear and intelligent e-houses a lot more capable and more cost effective to put in. So you can go ahead and go to the next slide. Thanks. So, and we'll go over two sort of use cases to justify these intelligent systems. And so the first case is kind of on the installation side up front. So implementing an intelligent power system using IEC and a combination of Ethernet IP and IEC 61850 reduces a lot of wiring. Like I said, the ability to be able to track those trips over a digital network greatly reduces the amount of equipment, installation, costs, etc. So up front, your cost is going to be lower to move to an intelligent system. So that's kind of the first piece. And then go ahead and go to the next slide. The next, I think we'll spend most of the next slides talking about the other justification, which is empowering your operations and maintenance people and to give them detailed actionable information quickly to reduce the unplanned downtime. And so this slide, just to kind of ground you, this is kind of what we, typical power components. So you've got variable frequency drives and overload relays, contactors, starters, etc. And with Rockwell's power devices, those all create a lot of information that we can pass on to the control system. Go ahead and go to the next slide. So with PowerFlex drives, those of you that know our Logix controllers really well know that automatic diagnostics was introduced to our L8 and our compact Logix controllers back in version 34. Well, excuse me, I'm getting over a cold. I got a little bit of a cough here, but PowerFlex drives also support automatic diagnostics. So that's kind of the first step. You basically just clicking a button or in the configuration allows all the drive diagnostics to be sent to the HMI system through factory talk alarm events. So go ahead and go to the next slide. So we couldn't talk about intelligent power without talking about automatic device configuration. So this has been around for a while. I think the customers that use this really like it. It's a great way to reduce downtime, especially unplanned downtime. But with the automatic device configuration, that configuration in that drive and the firmware is actually stored in the controller. So and using the AOIs, if a drive does go out, the controller will recognize it. The operator or the technician can put in a new drive, connect to the network. The controller recognizes the new drive and will put in the proper firmware and configuration. So you don't need to have your drive expert at 2 a.m. Come to the plant and configure that drive. Essentially, you just connect the power in the network, and automatic device configuration will do the rest. So just kind of a quick reminder. Go ahead and go to the next slide. So kind of taking up where Jacob left off with the device libraries, Rockwell has a power device library, and this is for devices like your drives, your not just the PowerFlex drives, but also the Kinetics drives, also overload relays, soft starters, power monitor, the power monitor systems. All these devices have associated libraries associated. And when I say a device library, I mean instructions that will sit in the Logix controller, as well as HMI graphics that you can put into VUSE. You can put these the power device library also into optics and our panel view products. So you don't have to just have one of our HMIs. You can put it in all of them. Now there's some extensions and with the brand new power library that are in optics and in view that you may not see in the panel views. But anyway, so this is go ahead and go to the next slide. So in addition, so with those libraries, you can also create what this would be like a system display diagnostic, that on that display you can put all your you can see your network devices, your automation devices, your PLCs, your IO, as well as your power devices. And what's important to note here is the standardization that's used by Rockwell to be able to troubleshoot these devices. So you can see on the bottom left there the legend. These are standard faceplates and standard graphics that are throughout all of Rockwell's faceplates and device and displays that will give you quick information. So without actually even going into the detail of the faceplate, you can see whether something's faulted, or you have a comms failure, or if you're stopped, etc. So that's part of the standard ISA 101 graphics format that Rockwell follows. So go ahead and go to the next slide. Okay, so I haven't mentioned it yet, but the I believe this is no, this is a different slide. So there are also some predictive maintenance tools that we can put together with the PowerFlex drives, excuse me, that allow us to do some intelligent predictive maintenance. Excuse me. Go ahead and go to the next slide. So this is an example of a PowerFlex drive and what some of the things you can see out of it. So there's a tremendous amount of diagnostic information that you can see without having to go to the drive, without having to walk out and go to the HIM module or whatever you may do today. You can also see the fault table listed there, but there's a lot of just very diagnostic information you can thumb through. You can also trend the speed if you don't think the drive is coming up as it has in the past. You can kind of look at trend information to track that. A lot of detailed information here that it really is only available through a network. Go ahead. So the IED library, this is for the switchgear automation side of it. This is a different library from the power device library. So these libraries, Rockwell is not in the switchgear business, so Rockwell has created library protection relays with different vendors. So Schweitzer, Multilin, ABB, those are the primary. And so those are devices that are connected to switchgear that pull in the switchgear diagnostics and trips and things. And so this information is transferred over typically on a redundant network. The IC61850 typically looks a lot like a PRP network. So you can see there's no real single point of failure there. And as you can see, the 16150 module goes directly into the Logix controller. So you're seamless. So once you're in there, you're seamless with the rest of the process system. Go ahead. And this is just to kind of give you an example of how you can integrate your process system directly inside of your automation, your process system and your electrical system. And the information to the operator may not know where that information is coming because it's all in one space. Go ahead, next slide. So this is a picture of an IEC motor control center, but the example here is just to show you how we integrate the network devices, the Stratix switches inside the MCC, so they can fit inside. Whether you have a DLR network or a PRP network or what have you, Rockwell's engineered to order products like this will build the network inside for you. Go ahead. So this is another thing that not a lot of people know about. So the IntelliCenter system has the ability to upfront create what we call a DCS ready interface, and so that can work with a PX DCS that's Rockwell, or it can also connect to a third-party existing DCS if the customer is unable to use the PX when you're upgrading the MCC. So this is something that is engineered to order and will alleviate a lot of headaches down the road if you don't integrate your MCC with your DCS when you design the MCC. This is also just to let you know that the medium voltage drives do come with SIP security now, so that helps with man-in-the-middle attacks, denial of service attacks, and things like that. So it creates a more robust, secure network. Go ahead. As well as the PowerFlex drives also support SIP security as well. Okay, this is an example of taking a parallel redundancy protocol network and incorporating the electrical devices into it. So typically in a PRP, what we do is there's a switch. Usually designate one switch to be a red box or a redundant box that will take whatever network you have in the MCC. So that could be a DLR in the MCC, but then that switch will convert that DLR information into a PRP for the rest of the control system. So that's just one way that the network could look. Go ahead, next slide. So this is a little more detailed example, and this is an example of an MCC being connected directly to actually a couple of different examples there. If I look closely enough, there is a redundant network connection to a couple MCCs, and then a single network connection to the other. But it's all together connected to the controller, and so all of that important actionable information from the MCC is going directly into the control system to provide value. Go ahead, next. So final slide here is it's just to kind of talk a little bit about more detail on the software side of how the data gets from one place to another. And so we use optics quite a bit to connect what we would call a third-party information. So that could be Modbus or 61850 that's not connected directly to a controller. We can pull that into optics, and so optics takes many forms and shapes. So it could be a computer, it could be a panel, it could be a module in the controller, but it can operate independently from your overall PAX system, which is what this diagram is showing. And so that's just another way of putting these networks together. But each system tends to look a little bit differently, and so that's how we can help you and your customers design a network up front that works well and that incorporates all the actionable information that you would want to have from your electrical devices into your overall process system. And I think that's probably the last slide. So thanks everybody, and appreciate the putting up with my coughing during the presentation. But I think I'll sign off and let others answer questions if there are any questions.
Yep.
Thanks
Thank
a
you,
lot for
David.
your time.